Please continue with your learning of complex numbers.
Now, one of the important things that we need to take a look at that goes with complex numbers is what we call the conjugate. Take a moment and write this down, please. The conjugate of two complex numbers differ only in the sign of their imaginary parts. Now, this concept is so easy. For example, find the conjugate of the following. Now, in conjugates, the sign only differs with the imaginary part, which in this case is a positive 2i. So, the conjugate of 3 plus 2i is 3 minus 2i. Like I said, super easy stuff. The conjugate of negative 2 minus I, well, again, the sign differs only in the imaginary part. So the conjugate of negative 2 minus I is negative 2 plus I. That is so easy. So you're probably thinking to yourself, what on earth is a conjugate good for? Simply put, when the conjugate of a complex number gets multiplied to that complex number, the I will go bye-bye. Well, if I look at this expression right here, the first thing that I notice is that it is not in complex number form. In other words, this expression does not equal A plus BI. Now, as I look at this expression, I notice that the denominator is a complex number that has I in it. And that is what's keeping this expression from being a complex number. So I must remove the imaginary part from the denominator. Well, the only way to do that is to multiply the denominator by its conjugate. And the reason why I want to do that is, remember, when you multiply a complex number by its conjugate, the I goes bye-bye. And it'll leave you with a real number in the denominator, and then make it possible to write it in complex number form. However, we must be aware that we can't just multiply the denominator by anything we want. We must also multiply the numerator by the conjugate of the denominator. So, 2 plus 2i. Now when I do that, I'm really multiplying by 1, because 2 plus 2i divided by 2 plus 2i is 1. So the result of this product right here will give me a number in complex number form. Now let's take a look at this process as an example. Again, I want to multiply the denominator by its conjugate. So 2 plus 2i. When I do that, I also must multiply the numerator by 2 plus 2i. So what I'm really doing here is I'm multiplying a fraction times a fraction. So I must multiply the numerator times the numerator and the denominator times the denominator. I'm going to do that using the area model for both the numerator and the denominator. So my numerator, my first complex number, is 6 plus 4i. My other complex number is 2 plus 2i. And now to multiply. 2 times 6 is 12. 2 times 4i is a positive 8i. 2i times 6 is a positive 12i. And 2i times 4i is a positive 8i squared. So the first product in my numerator is going to give me 12. 12i plus 8i is 20i plus 8i squared. Now the product of the complex numbers in my denominator. 2 minus 2i times 2 plus 2i. 2 times 2 is 4. 2 times negative 2i is a negative 4i. 2i times 2 is a positive 4i. And 2i times negative 2i is going to give me a negative 4i squared. And so the product of the two complex numbers in my denominator is going to give me a 4. Now, here is the kicker with multiplying by the conjugate. Remember, it gets rid of I. Well, notice what happens in my diagonal here. 4i minus 4i cancels the i's out. So, since the imaginary parts cancel out, that will leave us with only the real part in our denominator. So, we're left with 4 minus 4i squared. Now, let's clean house. Well, I know by definition of our imaginary numbers, I squared is really negative 1. So in our numerator, we're left with 12 plus 20i, 8 times a negative 1, which is negative 8. All over. Well, again, by our definition of our imaginary numbers, I squared is equal to negative 1. So we're left with 4. And negative 4 times negative 1 is a positive 4. So we're going to add 4 to 4. Now to collect like terms, 12 minus 8 is 4, plus 20i, divided by 4 plus 4, which is 8. Now when we look at our expression, we notice that in our denominator we have a complex number without an imaginary part. And that was due to the fact that we multiplied our complex number in our denominator by its conjugate. Now we need to ask ourselves, is this number in complex number form? And the answer is no. We need a plus bi, not a plus bi divided by 8. So now we need to use our knowledge of the addition of fractions to write this into a plus bi form. Now to undo the addition of fractions, 4 divided by 8 plus 20 divided by 8 times I. Now we're in complex number form, with one exception. We now need to reduce our fractions. So 4/8 reduces to 1/2 plus 20/8 reduces to 5/2 times I. So 1/2 plus 5/2 I is our final simplification of this expression. Again, it's in complex number form because our real part is 1/2 and our imaginary part is 5/2 I. So remember, when you divide two complex numbers, you must multiply the numerator and denominator by the conjugate of the denominator. That product can be simplified into an expression in complex number form. In example E, again, I want to simplify this expression. So I want to divide a complex number by another complex number. And again, I can't have a complex number in my denominator because it's not in complex number form. So I must remove the imaginary part of this number by multiplying the denominator by the conjugate of 3 plus I, which is 3 minus I. Now I can't just multiply the denominator by 3 minus I. I must also multiply the numerator by 3 minus I. Again, because I need to multiply by 1. Just like last time, I'm going to multiply using the area model. So in my numerator, I'm going to multiply 3 minus 5i times 3 minus I. 3 times 3 is 9. 3 times negative 5i is negative 15i. Negative I times 3 is negative 3I. And lastly, negative I times negative 5I is a positive 5I squared. So the product of the two complex numbers in the numerator is 9. Negative 3I minus 15I is negative 18I. And plus 5I squared. Now to multiply the two complex numbers in the denominator. So 3 plus I times 3 minus I. 3 times 3 is 9. 3 times I is a positive 3I. Negative I times 3 is a negative 3I. And negative I times I is negative I squared. So the product of the two complex numbers in the denominator is 9. And again, because I multiplied by the conjugate, the imaginary part of my complex numbers cancels out. Negative 3i plus 3i goes to 0i, and so the i's went bye-bye. And lastly, I'm going to subtract I squared from 9. Now it's time to clean house. Well, I know that I squared by definition is negative 1. So I'm left with 9 minus 18i. And 5 times negative 1 is negative 5. So I'm going to subtract 5. 9. Well, again, I squared by definition is negative 1. So negative times negative 1 is a positive 1. So I'm going to add 1 to 9. And again, continuing with my simplification, 9 minus 5 is 4, minus 18i, divided by, well, 9 plus 1 is 10. So now we can undo the subtraction of our fractions. So we'll get 4 divided by 10 minus 18 divided by 10 times I. And now it's looking really close to complex number form. Well, now let's just reduce our fractions. So 4/10 reduces to 2/5 minus 18/10 reduces to 9/5 times I. And this is the final answer for the division of our two complex numbers that we started with. And again, we multiply the conjugate of the denominator to both the numerator and denominator. And we simplify our expression. And we get our answer in complex number form with the real part of 2/5 and the imaginary part of negative 9/5 I. And I hope you enjoyed that particular Korncast.